Good evening. So if I get a confirmation that any audio is leaving my house, then I might just add one from IRC. There's Christoph. Then we can start. Yeah, so every time you message me privately on IRC, I'm going to get a notification. So if you could just ask me questions that way, it'd be easier because it's going to be really distracting. So I did a poll for today's stream, and so this is different than what I said I would do on Sunday. You people are weird. I mean, not very many people replied to the poll, to be fair, but a lot of people came and asked me what exactly extreme PowerPoint is, and they were really interested to see what it is. I don't know why anybody would want more PowerPoint in their life at all. I have no basis for it. I don't know why anyone would want anything that ridiculous. But the poll also agrees that people don't want extreme PowerPoint. So I did two. I did one through Twitter. Is it actually? Let me look at OBS. Yeah. So I did one through Twitter. And the Twitter one came down quite heavily for Crime Against Computers 3, which I expected because everyone likes crime. And PowerPoint came behind. The poll I did on the Fediverse, well, the first one I did sort of died immediately because I didn't notice it had a 10-minute default. But the later one actually came down on the satellite testbed tour, which I guess it says on the Fediverse that the nerds are really boring and they got their fill of crime from somewhere else. Maybe they went on 2 walks in one day or something. I was going to ignore the poll anyway. I had to do a prototype to see if the Crime Against Computers would work, and it does. Otherwise the stream would have been really dull with me just swearing a lot. And so what we're going to do is explore what I like to describe as my third crime against computers. And I know that some of you are going to be like, well, that's hardly any crimes against computers, but you've got to have a reasonable scale for what a crime against computers is. And so my first crime against computers is actually documented in the IETF RFC series. Well, it's a draft document, but it will exist forever. Let me see if I can find it. It's got a really stupid name. Draft UDP options CCO. That's in my history. So there's this internet protocol called UDP. We might be using it right now. UDP is sort of the minimal substrate you can have on a network. And so what it gives you on top of an IP protocol, which gives you network functionality, is it gives you port numbers. And port numbers mean we can have multiplexing. And so without UDP, we would only really be able to have one application on a host. With UDP, and with port numbers, we'll have one application on a host. With port numbers, we can have lots of applications on a host. And actually, we can have 65,000 connections to one port on one other host. And so it means you can have tons of connections, like loads of them forever. UDP is missing stuff, though. UDP is really thin. I mean, if we look up, I don't know the number for, UDP RFC, we see we get a sensible number. If we look up RFC 768, yeah, I knew that. I totally knew that. We get the full description of the user datagram protocol. It's like 4 pages long. Here is the packet format. Let me check. Yeah, it's actually on screen. Here's the packet format. Here's what the fields are. Here's how you calculate the checksum. Done. That's it. Page 3. That's it. It's got 5 references in it. UDP is a very thin layer, and it does a lot. And it helps, the internet run. UDP is used for things like DNS and streaming video, things where you don't want a lot of overhead. There's been this proposal in the ITF for a long time called UDP options. It's been pushed by Joe Touch, the angriest man on the internet. Joe Touch is great. He is responsible for a lot of progress in the ITF. He was the RFC editor for a long time. He thinks that UDP should have the ability to carry options, and these options allow you to do things. He's interested in packet fragmentation, but I don't know why, because it's just insanity. We should turn that off. But he wants to add options, and so I did some work on this. I implemented it for FreeBSD, and then he changed the WAR format, and I got cross at him. And we looked at how UDP options could be deployed in the internet, and we found that there were a large number of pathologies where sending UDP options would fail. And the way UDP options work is UDP carries a packet length. So unlike TCP, a UDP datagram is like, I'm this long, I have these 2 port numbers, and here's a checksum. That's what a UDP datagram is, and then data. there's nothing in the RFC series that says you can't have data after your UDP datagram. And so UDP options abuses that. And so what it does is it uses, this is the wrong document to look at. Let's look at, because there's a good picture in here. I totally know anyone tuning into the stream is going to be like, why on earth are we reading RFCs? But that is what you get when you make the mistake of joining me on the internet. So there's a great diagram in here somewhere. Nope. It's gone. Yeah, there we go. Here's the great diagram. I'll highlight it. It's a great diagram here. So this part here, the UDP length, is what is defined by the UDP length field. Thankfully, the IP datagram has a length as well. In IPv4, it's the IP header length, and IPv6 is the IP payload length. Using these two numbers, if the payload length minus the length of the datagram is not 0, it means there's extra stuff there. And we can abuse this to send more information. And this is how Joe proposes encoding options to send with UDP. And it gives us more stuff, and it's pretty cool. It allows you to implement the most complicated acronym on the internet, which is DPLPM2D, which is something else I've been involved in. Say that 4 times fast, and I'll be proud of you. But there's a problem here. The internet we have has grown over sort of like 30 years. And there's a lot of assumptions about how the network works. And what we found when we measured for UDP options on the internet is that there was one pathology covered about 30% of the paths that failed, where the UDP checksum was not being calculated properly against how long the UDP datagram was. And so we actually figured out a way, and Rafael Azulo, he did this work. It was his crazy idea. I just helped. We did this work, and we found that you can carry an extra option with your UDP datagram, which we called the CCO, or the checksum compensation option. And you can abuse the CRC16 we use on the internet for checksums, and you can cause a deliberate collision so that the main pathology of checksum failure will checksum, and it will result as the same as if the extra data wasn't there. So a host that checksums properly will get the right answer, and a host that checksums the UDP datagram and everything after it will also get the right checksum. And this is what I think of as a crime against computers. And I think this is a particularly egregious case. And look, we've got to write all these words. And we've got a paper which is going to come out this year about it. And you can go and read more, or you can ask me questions offline. But yeah, that's what I would describe as like a crime against computers. It's not just you've done something atrocious, but you've really flaunted all of the pure reality and how we have structured the world. And so I thought we'd do another one today. Oh yeah, so someone's sending me private messages. G Schwepp, if you were to join the FreeBSD channel on irc.geekshed.net, then other people could see your questions. Christoph wants me to swear, but I'm not going to. Yeah, so I thought we'd do another crime today. Let me bring up OBS and let's just switch to the camera. Nope, this one. That's the right way up. No, it's the wrong way up now. I don't understand what happened. I flipped. Oh, okay, I didn't flip it here. Let me flip this. Because otherwise I'm going to be really confused if I don't do the transform, because everything's coming up backwards and left and right's wrong. Let's take some stuff away. So, back camera. For doing the videos for the FreeBSD hardware hacking, I need some extra perspectives. What I want to be able to do is have this top-down shot that you're looking at right now, which is good for giving like a broad idea of where things are. But I also want to be able to do some pictures from a side angle, so that you get some more three-dimensionality and you get a nicer picture. And I have a nice macro lens for this Nikon camera, which is here. Annoyingly, this Nikon camera won't give me video in the way I'm getting it from the Canon camera, because Nikon are just dreadful at software. And so what we want to do is get some video out of here. And so first we're going to talk about single-board computers again, because this is hardware hacking stuff. And so what we have here, you can go away, little robot, we'll sit in this corner. is a BeagleBone Black. It is a single board computer. It's actually sort of one of the sort of second-ish generations. It's quite contemporary with the original Raspberry Pi. It's a much better system on a chip, and it's really popular for doing hardware stuff with. It's ARM7 because it's quite old. And it is really cool. I really like it. It's got an absolute ton of I/O on it. And it has these amazing little onboard microcontrollers called PRUs, which are programmable real-time units. They share address space with the processor. And that means that if you need to do something with like a sort of hardish real-time guarantees, then you have two processors on board that will speak them. And so people have built logic analyzers with these, and they've built other great stuff. And I really like these, and I just have them lying around. And it's also a good example of how we have a system on a chip. And so, where's my pencil? The system on a chip on the BeagleBone Black is this chip here, and then the other two are RAM and like a memory controller or something. The system on a chip is not the board. The board is just a specific implementation with all the electronics there to support it. And so TI, who are behind this, and they have a weird open-ish project, have supported this. And so there is something called the Pocket Beagle, which is absolutely tiny. And that is the same system on a chip as the BeagleBone Black. It's actually this big sticker here sits on top of it's called a system on module. And the system on module really is at the level where you just sort of have to give it the right power, and then everything is there. It makes it really easy to include in your designs. This is how the IMX5 stuff works as well. Like a lot of people will use a system on module for doing designs and then maybe break out if their costs get to the right point. And the Pocket Beagle is so small. They call it key fob sized. I don't have anything to use for scale. Here's a USB Ethernet thing that doesn't work on OS X for scale. Or FreeBSD, actually. I don't think it worked on FreeBSD either. It's dreadful. It doesn't help you get a sense of the size. So the BeagleBone Black is sort of described as like a credit card size computer. And it's got a bunch of hardware on it, but for today, actually, we're interested in the fact that it has Ethernet on board, and it will do USB on the go, and it will do USB on the go really well with FreeBSD. And so all I've done is I've prepared an SD card. Is vanilla FreeBSD apart from one package I've installed that I've not done any configuration. And so we're going to connect to this like we connected to the boards last week. So last week we connected to NanoPi Neo LTS, and we used USB Ethernet to do that. With the BeagleBone Black, we don't actually have to use USB Ethernet. What we can do is use the USB on the go, and the default profile that FreeBSD sets up for USB on the go is to act as a USB serial device. And so that's what we're going to do. So there is an SD card in the BeagleBone Black. I will turn it towards the USB cable I have. This USB cable is plugged into my Mac. And then we can go back to the everything view. I'll bring this terminal up. You can go away. And so we don't actually get the serial port until quite late in the process. And so let's just you need to add do in your loops. Okay, there we go. And so what we have is the default ID for FreeBSD's USB serial is FreeBSD, and it's not 11. It's not saying it's FreeBSD 11. It's saying it's like port 1, device 1. And what we can do is we can connect to that just like we would any other serial port. It has a different name. Hunter 2. It's slow. I don't understand why. We'll give this a second, and then we'll go to the fallback option, which is to use the USB serial thing I have set here. This did work before, but this could easily be an OS X thing. So I've got this working on FreeBSD. Because I'm not that good at planning ahead. I wonder what's wrong. Oh, I know what's wrong. USB serial doesn't work on this Mac for writing, and I don't know why. So give me a second. I'm going to acquire more computers, and then we'll be okay. I had a panic there that I wasn't going to have enough mini USB cables, but apparently I have every mini USB cable in the world. Okay, so we're going to use this USB serial to connect because my Mac is stupid. It doesn't change what's going to happen though, so it'll be fine. So what we're going to do is guess the pin out of this and then SSH to my laptop. And then connect to the serial, do some serial stuff, and we'll get onto the actual fun. This is ground. This is the worst documented pin header in the world. You can't find it on any schematics. And all it ever says when you look it up are the colors for the Adafruit cable, which doesn't help if you don't have the Adafruit cable. Hunter 2, dmessage. Once again, we're connecting over USB serial. Okay, now when I press enter, nothing happens, and that's probably because the transmit and receive lines are swapped on the USB serial, so I will swap them over. Now when I press enter, stuff happens, which is what we want. Nope. Okay. Default credentials on FreeBSD are root and root. And so what we actually want to do is we want to reconfigure the USB on the go and the BeagleBone Black so that it will act as a USB Ethernet device. This is what I don't know if Raspberry Pis will do it. A lot of Linux single board computers will act as an Ethernet device. And this allows you to get networking straight away, so you don't have to do a lot. And thankfully, Edward wrote a great USB on the go page for FreeBSD, and so we will look at that. I've been here before. And USB on the go supports actually an absolute ton of profiles. I think FreeBSD only supports these 3, but you can actually have something like a single board computer do act like a MIDI device. Anything that has like a common device class, so a CDC class on USB, and you can get to do that. No, we don't want storage. I don't know how the storage one works at all anyway. We want to act as a virtual device. We have to do 2 things. We have to load a kernel module and set a syscontrol, and then everything will be okay. Yeah, I don't know. Is this, Christoph, have you seen the no write on USB serial before? Because I only noticed it in the last week trying to set this stuff up. And I've heard other people tell me that it's fine and I'm insane, but I tried 3 different computers, 2 different USB serial devices, and 2 different SBCs. But before I settled on this being the answer. So it's a bit silly. What we want to do on this is kill the pain because it won't go away. So this is on my Mac, and we want to look at the network devices we have. There's quite a lot of them. VirtualBox makes tons of them. I don't understand why. And so will WC give me anything useful? So it outputs 81 lines of config. And what we're going to do is we're going to run these 2 commands. So I'm going to copy and paste them. You should always copy and paste. So we're going to load the kernel module, and normally you'd see something. Oh well. And then we're going to change the mode. And when we change the mode on the Mac, we will see, I won't run this command yet. So when we change the mode, if we do that loop I did before, we'll actually see the USB modem go away, and we'll get a USB Ethernet device. And so we change it to there, we get some kernel messages, and we see that it's gone away. And if we look in ifconfig again, we have 6 more lines in ifconfig, which means we've got a USB device there. I don't know what name USB devices use. I'm going to guess that it's EN5, and we'll configure it like it's EN5. And if we're wrong, then we're wrong, because we're just going to live with what it is. So what we've done is we've set up the BeagleBone Black so that it has now got 2 Ethernet interfaces. And that really helps us because we have this goal of getting video out of this little camera. And the way we're actually going to get video from the camera, there's now too many computers here. The way we're going to get video from the camera is by using one of these. This is a HDMI Ethernet network extender. What it does is it takes in HDMI in the HDMI hole. It outputs Ethernet from its Ethernet hole. And it's got a matched pair. And so the other side of the pair takes in the Ethernet and will output HDMI. There's 2 types of these extenders on the market. There are passive ones. They're designed to run over Cat6, and they just take the pairs of the HDMI signal and they send them through the pairs in the Cat6, and it's really like an analog process. They are not what you want for this. They are really cool though. If you have good structured cabling at home, it's a great way to move like a streaming PC or something further away from your TV. I mean, it's not a problem really anymore. But they don't work for this. What you can do with the sort of analog ones, which are just running through Cat5, is you can use them as a glitching machine, because you can mess with the cabling you have. So if you do them over a really short run of like Cat5e rather than the Cat6 they want, everything is okay. If you do like 10 meters of it though, you can mess with the cable and you can introduce noise and you can get cool things out. And if you want to do that as a project, that's actually pretty interesting. These extenders are Lankin extender things. They've been sort of reverse engineered. They don't do a passive conversion. Instead, what they do is they take the digital signal and they pack it into an MPEG-2 video stream. I think they take the audio as well and bundle it into a different video stream. And then they broadcast it on the Ethernet segment at however, like 20 megabit or whatever it is. And what that is they take the HDMI and they act as a HDMI capture device. And so this little camera on this side has one of these really stupid mini HDMI ports. And it will output the rear display of the camera. I don't know why they always do this. It'll output the rear display of the camera over HDMI. And if we have a HDMI capture device, which we do, then we can digitize this video. I mean, it's already digital, but we can capture this video. And we can do it for something which costs like 20 quid rather than a real HDMI capture device, which in the past would cost a lot more. Dozens of pounds. Oh, everyone's sad about OS X. Yeah, me too. Okay. And so that is how I'm planning to get the close-up video. I think the first thing I'm going to do, though, is I'm going to add to this camera my macro adapter, so I don't forget to do it later, because the macro adapter does make everything cool. The macro adapter was like £3. It rattles because I dropped it. You can get me a non-rattling capture macro adapter for a camera by giving me money through the Ko-fi. You can also just give me money and I'll buy toys or food. I might buy food. So this macro extender just screws onto the front of the lens. And what it does is it gives us a shorter minimum focus distance for the camera. So normally the minimum focus difference for the camera is something like 11 centimeters, and this reduces it down by some factor. This says 0.45x. I don't know how to really verify that their maths isn't silly, but what it does, practically in the upshot is it means that we can take the camera and we can hold it like here, and we can still focus and we can still see what's going on. And hopefully you can see how that would help when we're trying to capture video for doing hardware stuff. So what we need to do is get some of our magically digitized HDMI into the BeagleBone Black, and then we need to get it to the computer which is running OBS. And so what we're actually doing here, and why this is what I would describe as a crime against computers, is we are going to use the BeagleBone Black and its USB on the go to be a USB Ethernet device, because I've not been able to get a USB Ethernet device that works with OS X, but the BeagleBone Black works with OS X. We have a network interface here, and so I think we can do this. I think we can do this abomination, and then we'll get better video into the Mac until I can buy a real USB Ethernet device. And so that is what we're going to do next. And so I need to figure out how to get the bundle of Ethernet from underneath my laptop and get power to the HDMI extender and get Ethernet across. And so because obviously tomorrow is International Workers' Day, we have to use the government-sanctioned color of patch lead. So we will. The other side will go to the extender, and then it will go away because it needs to be plugged in where there's actually power, and there's not power here. And hopefully the cable will not try and steal. Yeah, okay, that works. So the cable won't try and steal the BeagleBone Black. And I had to really pull to get the mini HDMI out of the nest of cables. At this point, I'm very jealous of Christoph because all he has in his setup is a microphone and a terminal. And I have two laptops and like 8 computers and all these cameras and stuff. But we have to look at Christoph when he streams. And that must make him sad. The Nikon camera is... oh, I know something happened. Oh no, it's fine. The Nikon camera is not very happy if you plug in the HDMI while it's turned on. It gets quite sad at you and complains. Overall, it's a dreadful product and I wouldn't buy one. And so that is plugged in. And so the Nikon camera is plugged into the network extender. I don't know if you can see, if I lift this up. The Ethernet port there is flashing very quickly. It might not actually come through in the frame rate, but it is flashing very quickly. I can see it. That's the thing to check. We still have our Ethernet here. And so what we're going to do is we'll look at our network interfaces. We have a UE0, which is our USB Ethernet. And so we need to configure the 2 interfaces. And so I have done this before on my amazing website, on my talks page. You can actually find the talk I gave at EuroBSDCon in 2018 on hacking together a FreeBSD streaming box for as little as possible. I have to check if it's actually visible. Yeah. And this talks through, these slides talk through, and the talk talks through using these sort of HDMI capture devices to build like the minimum viable streaming thing that you could use for a user group or a meetup. Not necessarily like a big conference. I do actually know that Hdmi, so the KDE conference, they use these devices and they feed them into OBS, and that's how they do streaming. And OBS should support this. And now I have to flick through all my slides to figure out what we did before. I hope you like my diagram. It's ASCII art turned into an SVG. It's all a big story. And so these slides actually... Oh, yeah, okay. Is that up? Yeah. So this is a photo from my office in the past. And this is using one of the wrong HDMI extenders. This is the picture of Pluto we have. We don't have very many. In the background, over to the right, is... my Deck Pro. I don't know if you probably don't know this. Deck actually made a desktop model of the PDP-11, and then they were scared they would cripple the PDP-11 market. Like they would Sherlock their own market, and so they crippled it so it wouldn't run software, and so it runs a dreadful operating system called P/OS, which is no fun at all to play with. There was a Unix port for it. It was a port of Vnix. I have one of these. I picked it up from someone's father that had passed away, and I saved it from a bin. I don't want it. I want it to go away. But thankfully, I don't have to look at it anymore because I'm not allowed into work. On top of there is the phone I had as a child. I'm not old enough to have grown up with a rotary phone, but we had one because it was in the house when we moved in. And that's the cool sort of glitch you get. So you get like enhanced Pluto, if you have Pluto. Instead, these are the things we're looking at. If we were to, we can just look on the wire, right? Because we have the computers. If we do, so we need to give our USB Ethernet, we need to give CPSW0, our actual Ethernet, an address in the subnet that the adapter is broadcasting in. And it's broadcasting in 192.168.10/24, which very annoyingly is also the network numbering of where I am. And I don't want to feed this broadcast traffic into the wireless segment here. So we're going to do a bridge. But if we set this up, see, good as an address as any. Once we've done that, we can actually dump, and we don't see any traffic. Interesting. But there was one. I don't understand. These things do also crash sometimes. Where's the reset button? It could also just not be sending any traffic right now because there's no video being fed into it. I pressed the reset button on the side. We'll see if it comes up. This might all fall apart. I got it to work the other day and I tweeted a picture, so you know I'm not a liar. But if none of this works, there we go. See, there's our broadcast traffic. And what we have are big series of full-size packets and big series of zeros. And I can't remember if that is just padding for timing to hit the frequency of the frame rate the HDMI expects, or if it is something else. But yeah, okay, so we have video coming through, so that's good. What we could do is we could just bridge these two interfaces together, which is the first thing I tried. But then I hit the problem that the network numbering is going to cause a mess between the Wi-Fi and the Ethernet. And I played with a jail. And then I remembered that I did a whole presentation about doing this. And I have a slide that explains how to take the broadcast group and feed it into unicast. And so that's what we're going to do. Let me look at whatever this question is. Nope, just the terminal moaning at me. Come back. So on the slide, we have the socat command. The netcat part of the command is cut off. It's fine. I can netcat. If you can't netcat, you should learn to netcat. I think you can do the broadcast capture with netcat, but netcat is a bit finicky for these things. socat will do the actual magic for this. And so what we want to do is take this traffic and feed it to, as UDP, feed it to our other interface. Like that. This will stop immediately because it says we can't assign the requested address. And this is because we've not configured the address on the USB Ethernet, so the USB on the go, or the address on the USB Ethernet of the Mac. And so we'll do both of those. So this. We'll do that. That one's the easy one. $102. I'm going to do a TCP dump. Oh no, I need to do two things. So to test this, to make sure we're actually getting traffic through, I'm going to use netcat again. I'm going to do it in LKU mode, which is listen, take more connections, do UDP. And we're going to listen on 10.1.1.1, and we're going to listen on port 5000. And we're directed to dev/null. I'm also going to do a TCP dump on EN5, just to see if we actually get traffic. This is because I'm a show-off. We're on a bridge. It moans at us. Why is it moaning at us? Let's just do netcat then. Netcat is great for debugging networking problems because you can send traffic where you want it to go and you don't have to worry about it. I was trying to do TCP and we're not listening on TCP. So it's working. I don't know what it was complaining about. Am I even complaining about the multicast side? I don't think so though. So we will do this one. And what is in our TCP dump of value? So we see the TCP connection that we tried and failed. We're getting traffic from that port. We're listening on 5,000. Port unreachable. But the port is reachable. Well, that's from them to here. That's fine. I expect that. So, why is SOCAT complaining? Because I picked a random address rather than the correct address to use for the interface. So, instead of picking the 24 address, let's just change the netcat. Instead of picking the 24 address, I should have picked 2 because that is the address that we're going to look for in our broadcast. Broken pipe. But we expect the broken pipe because this netcat's not running. Okay. And it's happy now, which means that we should be getting packets through. And so what we need to do is get the video. Well, I need to get the video here to see if it exists, but that doesn't help you see it. We want to get the video into VLC. Does CVLC work on a Mac? No. Now we're at the problem where I have to remember how to type commands into VLC. If we look back at these slides, you'll see that there is a command here which is CVLC, UDP, and this. And that just tells VLC to pull UDP traffic in on any address on port 5000, and then it will render it. And the MPEG-2 has enough metadata that VLC will happily render it. No problem at all. And so we need to get that into VLC. I don't know what's going to happen when I open VLC. Let me check my VLC and make sure it's not all memes. File, open recent. Oh, okay. It's all hardcore videos, so that's fine. I don't mind if you see that. So I need to find OBS. I'm going to add a window source for OBS on top of this one because that's what I want to do. Add a window capture. Here we go. VLC is now far too big. Okay, so we have a small VLC on top of some slides. And I promise I wasn't joking. Like, it literally is all hardcore videos. Like, who listens to this much happy hardcore? There's something wrong. Don't judge people for their music. They can't control it. And I can't remember how to open network things, so we'll try network. UDP : / at. It did not complain. What it is not doing though is it's not being sent video right now because there is a netcat. Oh, I should have put this source on top of something with my terminal. And so what I'm going to do is I killed the netcat here because we don't need it. So I killed the netcat on my Mac we were using for debugging. I'm going to start this one. You'll see it hasn't complained this time. And then if I find OBS in my million windows and we look at this one, we see an amazing message. What we see here is the debug screen from the HDMI capture device. And so if I turn this camera on, it moans. And then it will take some time because there's actually quite a lot of latency in the system now because it's, I mean, I'm looking at this through the VLC preview, the OBS preview. But there we go. So here's video. I don't know how to hide this menu. I've never seen this menu before. If I flick this. Yeah, okay. And so what we're seeing is the video from my little Nikon camera. And if I move this over here, and we wait several seconds, you see that we can get a really nice, and obviously this is handheld, so it's not going to be as good as it would be on a tripod, but we can get a really nice close-up macro shot of the NanoPi Neo. And if I switch the feed to everything, you'll see that that is how I'm holding it. I'll put the camera down right next to it. And we come back to this one. Yeah, flicker through time, and it will do... okay, it's doing continuous autofocus over the top of something. We put it on a pencil. Yeah, we get like a really nice close-up side shot of the computer. And I think this will help us... it will help me show what is actually happening, because you're not going to be looking at this stuff from above if you're watching a video. You're going to be like looking at it with your hands and trying to poke things, and you shouldn't poke the things because you'll break them. But right now what we're doing is overkill, and OBS actually supports a VLC window, and so I'm going to delete this window. I've never deleted one of these. I don't know how to do it. I thought I would have right-clicked and it would have said delete. Oh, I see. The minus button. Are you sure? Yes. So that's gone away. We'll go back to everything. I'm going to add another source to my everything feed. This time it's a VLC source. I'm told that this should just work flawlessly. I am skeptical, but we'll see. It's asking about playlists, so maybe add path / URL. So UDP / at 5000. Hit OK. Hit OK. And then I don't really know what I was expecting to happen next. It could be on screen and I can't tell. So I'm going to try sending this window to the back. Order, move to bottom. Yeah. So I am not seeing it. That is a shame. So that is going to take more faffing. I wonder, what other options are there? Stop video when not visible. Oh, maybe this died. It did not die. Oh, I understand. I will quit VLC on my Mac, and I will kill the stream. Oh, there we go. And now we get video because we weren't getting packets before. And there we go. So coming through the Twitch, you're getting a much bigger version of the rear of my camera, and I can shrink it down. I actually think it's quite annoying that we get all of the extra display, and I'm not sure if that is Nikon thinking that's what people want. I mean, do you really want to see the 20-minute recording time? But it's pretty cool. And this is actually really straightforward, right? I mean, this is an abomination. This is a dreadful way. This is not the way you should make a USB Ethernet thing. You should just spend 30 quid. But I don't have that hardware budget right now, and it feels sort of wrong buying loads of equipment during the end times. And so instead, I worked with what I had here, and that's what this makes this a FreeBSD hardware hacking stream, I guess. Now we can look at hardware bearer. And so this is partially my setup here. Jampiet asked that I talk about how I do the streaming. And so I'm going to pull this camera back, and I'm going to take off the macro extender. I'll actually show you what the video died. Looks like the VLC's died because I'm holding the camera in my hand and it's not updated. But we can always do that. Try starting it again. Oh, well, that's a real shame. Yeah, I don't like this. I'm gonna remove this one and do it properly with actual VLC. VLC. Just give me a second while I add more sources. Window capture. Yes. VLC media player. Okay. Make you much smaller. You're going to resize anyway. Open network capture. This sort of thing where you have to do all this awful video magic to get stuff working is not easy to pick up. And I'm happy to take questions from people. And I'm definitely not the best person to actually talk about this, because I only done this incidentally, really. But a lot of it is just knowledge you pick up by doing it over and over again. You learn things like VLC is magic. But you also learn about like FFmpeg and GStreamer pipelines, because they're pretty cool too. And so I'm going to put the macro extender back on, if I can figure out which way up it goes. So I put the macro extender back on, and I'm going to hold it to the NanoPi Neo because this is what I was trying to show before. So that is the sort of shot we can get with the macro extender on the lens. And this is why it helps us take photos of stuff. And this is what we can do without the macro extender. And so we can get as close, but I can't kick the camera to focus very well. Can only focus from maybe this far back. And so what you end up doing is you end up sacrificing quite a lot of your frame. And so you lose some of the video. And obviously the video coming out of the camera is not great because it's the rear screen of the camera and it's like 640 by 480 or something. But if you wanted to do something like the introductory pictures I had on the hardware hacking slides, which aren't on these slides I'm seeing, I did a focus stacked shot. I'm going to put the camera down. Focus stacking, what you do is you take like tons of pictures from like a fixed perspective, and you lock where you are, and you adjust the focal point. And this allows you to play against the lens. And so the lens will give you great focus over a very narrow distance from the sensor. And you can play against that by just walking through the full range of the focus it does. There are mechanical systems that do this where you put the camera on a slide and you fix the focus and it will slide forwards. And then there's software which will stitch it together. And this allows you to take a photo really close up of electronics, which I do all the time and I don't know why. Really close up of electronics and then pull them together and you get a full focus across. And this is how I found that it really depends on the white balance, because I lit something in mauve, that color which does not exist, and the focus stacking software did not know what to do with it, and it sort of threw everything all over the place, and it made quite nice like art, but it wasn't great to look at. Okay, what I was doing is, because on the Nikon I have a 10mm pancake lens which is quite wide angle, I was going to show you, sorry I hit the microphone, what the streaming setup looks like, and I can't quite get it far enough away. And so I'll come around. Here is the Canon camera and the microphone and all this stuff. This must be the most disorienting video in the world. And there's laptop 1 and laptop 2, and then you can see that it's just like this mess of wires, and it is a nightmare to do anything. Okay. I planned to go for an hour. I have presented something from my past, which was quite embarrassing, and I'm sorry for doing that to humanity, but we needed to see if we could get the UDP options through. I've told you about crime number 3. Crime number 2 is not very interesting. It's me doing the same thing, but using a single board computer as a USB serial, which is cool, right? Like, it's a workaround. Like, this is a workaround. And it allowed me to do whatever stupid thing I was trying to do that day. But it's not good. You should definitely buy the really cheap components you can get, because they'll work well. Not that I'm saying that I don't have USB Ethernet. I have this dreadful D-Link one, and I have this dreadful no-name one, and they don't work on OS X at all. The dreadful D-Link one will only do like 8 kilobits a second on FreeBSD, so there's more problems with it as well. Yeah, and so I'll take some questions for a bit. I plan to be on for an hour, so there's 10 more minutes. I forgot to get water, so I've just been sat here. Unlike Christoph, I keep my drinking problem to myself and off the video. I tried to ask a question in the Twitch chat, but I realized I did it in a private window. Yeah, Ed, I don't know how I get these things. And you'd think because they are like a common device class that they would be quite an easy bar for a vendor to hit. But this D-Link one is really upsetting because it's USB 3 and it should work well, but it negotiates modes in a weird way so that it ends up getting absolutely terrible throughput, and I don't understand why. I've not dug into it because I tend to find it when I have to install a system which doesn't have Ethernet, and I plug it in, and then it turns into a nightmare. But yeah, it's really annoying. It'd be good to have lists of these. Okay, no one seems particularly that bothered. I've just been brought water. That's very confusing. I hope you enjoyed me doing stupid things. I will do another poll for the next stream. I think I'm going to stream on Sunday. It depends how the celebrations of Workers' Day go tomorrow. We'll see. But I'll do another stream on Sunday. I might actually try and do some PowerPoint so that I can start making the videos. But PowerPoint's really dull. So I might need some convincing. I also... the other option in the poll was a tour of the satellite testbed. I have to tell you that there are no satellites involved in the satellite testbed. What we do as part of our research at the University of Aberdeen is we look at stuff over satellite protocols, and we have a FreeBSD-based satellite emulation platform that uses DummyNet, and it's all real straightforward, simple stuff. There's nothing very fancy in it. During the COVID lockdown, the control node for it died, and a colleague, very thankfully, she recovered it from the building, so it's now in my flat. And so, I mean, there's no difference. I would just SSH to it, but maybe going through the configuration of that and how we use this and how we use DummyNet for things might be interesting to people. I'm going to figure out a third one. I think it might be Mystic Writing. I'm going to try and keep the poll options very vague so I can change my mind if I can't be bothered going through them. But yeah, so we have that. I wrote a bit about the work we've done with satellite in the FreeBSD journal in the most recent issue, or the last issue, I'm not sure, because they do like a 2-monthly thing. And you should read it, and it's good, and you should support the FreeBSD Foundation that makes a great publication. And so I'd like to thank you all for joining me on this awful idea I had, and I'm glad it worked out, and there wasn't that much chaos, and we get some nice out of focus pictures of a computer now. So thank you, and I will talk at you again in the future.